In the last video, we discussed alkenes, and we said that alkenes undergo some sort of reaction called hydration, and they produce alcohols, right?
Yes.
We said alkenes plus water. Do you remember the catalyst?
Potassium manganate.
Phosphorus.
Phosphorus.
مش فاكر. I don't remember it. Phosphoric. I don't remember it now, but we will say it again. Alcohol. So basically, something like that. This is called ethanol. Okay. So there we will be discussing a third family of organic compounds. Third family called alcohols. So what's special about this family? I'll draw this very simplest alcohol. It's called methanol. What's special about this?
That they have extra hydrogen. They have extra oxygen.
No, the special thing about them is the A hydroxide. This is the functional group, hydroxide. This is special. What makes alcohol special? Okay, can we draw the water molecule? Can you draw the water molecule? A water molecule, a very simple water molecule.
Hydrogen. Two hydrogens and.
Draw it, please. Okay, this is the water molecule. Do you find some similarities? Okay, if you make something like this is H. Actually, it's an H and OH. Okay, this is minus, this is plus. So it's somehow alcohols are similar to water. Okay, instead of the H, if you replace the H with the alkyl group is the sort of CH3. It's called an alkyl group. This is what methanol. This is the very basic alcohol. Okay. So we will be talking about some properties of alcohols now. Properties of alcohols. So this some sort of OH bond in water doesn't have some sort of polarity. The H is somehow positive and the OH is somehow negative, right?
Yes.
So it have some polarity, right?
Yes.
Polarity. H is somehow
Positive.
a little bit more positive, and the OH is a little bit
Less negative.
negative.
A bit.
So it has polarity. Polarity is very important. Why is it important? Because it increases the boiling and melting temperatures of alcohols. Okay? It's important for that. It increases the melting point and the boiling point of alcohols. For example, methanol has a boiling point of melting point of negative 94 degrees Celsius. What is the boiling point of methane?
Methane.
Methane. What's the boiling point of methane? Let's see it. Boiling of methane. Negative 161. So there's a huge difference, right?
Yes.
A big difference. Negative 0.4, I think. So this is the boiling point. And they are relatively very similar, right? Methanol has an OH and methane doesn't have an OH. So what about the boiling point?
The methanol has lower.
Has much higher boiling point. So it's 64 degrees Celsius. What about the methane? Let us check. We got the boiling. This was the boiling point of methane, not the melting point. This is the boiling point. This is the boiling point, not the melting point. Can you see the difference?
Yes.
Very big. What about the melting point of methane? Let's just check it out. Negative 182. This is wrong. Negative 182 degrees Celsius. While methanol has negative 94. So there's a big difference.
Yes.
And the difference in the boiling point is even larger. Okay. So why is that? That's because of the polarity. For example, here's a methanol. Another methanol. There's some sort of love between this hydrogen and this oxygen. It's delta positive and delta negative. some sort of love, attraction. This attraction increases the boiling and the melting and the boiling points. Okay. Also, another property is that they have low volatility. Low volatility. What's volatility? It's relatively low volatility. What's volatility? What's volatility? Volatility, it's how easy something evaporates. Or like this is volatile. It evaporates easily. How easily
بس
something evaporates.
so if it has a high volatility, it doesn't evaporate.
No, high volatility means it evaporates very easily.
But it's known for alcohol.
Low volatility, it evaporates not very easily.
But alcohol is known to be very fast in evaporating.
Alcohol, it's a very good question. Ethanol is very volatile. Not very, it's volatile.
Yes.
But not but when you increase the size, for example, hexanol is not that volatile. So very good. Alcohol, or let's say ethanol, is volatile. Okay. But hexanol is not volatile. Okay?
Okay.
Okay. So the similarity between alcohols and water makes them also what? Dissolve or mix in water. They mix
Easily together.
with water easily. What is that called? What's that property called? They are miscible. They are what? Miscible. They are miscible. Uses of alcohols. Finish the general properties. That's uses of alcohol. طبعا معاها زيكو. Okay. They are used as a solvents. What's a solvent?
It's a liquid.
What does it do? It dissolve other things. A solvent,
Dissolve.
it dissolve other things. What is the name of the thing that it dissolve?
Solutions.
Solvent and other ايه؟ Solvent and
Solvent.
soluble ايه
إيه
بس
مش فاكر.
يا رب solute
مش فاكر الكلمة دي خالص.
solute. Okay, solvents. It's used as solvents, for example, in paints, glues, and after shaves and perfumes. Okay, what else? They are used in domestic burners. Something like, it's not like gasoline, but some liquid, some sort of simple burners have fuel for them. It has ethanol and some sort of they add a poisoning thing to this ethanol for people not to drink it. Anyways, they are used in domestic burners. Domestic burners for heating and cooking. Usually, ethanol is added, or so a poisonous substance is added to ethanol. Why do they add something poisonous to ethanol?
So they don't eat it. Or
So people don't drink it. Ethanol is basically كحول. Okay. And the last use is mixed with petrol for car fuels. This is, let me be ethanol. This is ethanol. Also ethanol. And also ethanol.
But don't people drink ethanol?
You don't drink ethanol. They put ethanol and other things on each other. But they don't drink pure ethanol. If someone drank pure ethanol, I think he might get alcohol poison. He might die. I don't know, but anyway, any quantity of ethanol harms the brain. It's a very recent study that found out that even very small quantities, they do harm the brain. Anyways, so these are the uses of alcohols, mainly uses of alcohols or ethanols. Okay. Okay. The last thing in alcohols, it's the chemical reactions of alcohols. Chemical reactions of alcohols. So I said that the very basic reaction of any organic compound is what?
Combustion.
Combustion. No, combustion. Ethanol. What's the formula of ethanol? CHOH. C. Ethanol is how much? C how much?
Ethanol is 2.
C2. H how many hydrogen atoms?
5.
5. CH, C2H5. How many hydroxides?
One.
1. Plus oxygen. What will it produce? Carbon dioxide plus water. No hydrogen. Just carbon dioxide and water. So can you balance this equation? How many carbons entering?
Two.
2. So we must have 2 carbon dioxide atoms, molecules, sorry. How many hydrogens entering? 6. So we must have 3 water molecules. So we have 3 oxygen atoms here, and we have 4 oxygen atoms here. Can you balance it? Actually, we have here 1 oxygen atom, so we just need 3 oxygens, and that will give us the 7 total oxygen atoms that are in the right hand side of the equation. Okay, this is the first chemical reaction of alcohol, and this is used in what? Domestic burners, right?
Yes.
Combustion. You don't have to memorize this equation, but you should be able to actually write it in the exam without memorization. Okay? It's simple, right?
Yes.
Okay. Of course, plus heat. That's the whole point of the combustion. Okay. Another chemical reaction for alcohols. What is it?
Oxidation.
Oxidation. What is oxidation?
Adding oxygen.
Adding oxygen. Very good. Okay. So we have ethanol, C2H5OH plus oxygen. After adding oxygen, what will happen? It will we said it in the alkenes video, I think. We said it before, so I can't remember where. Yeah, okay, add oxygen. Let's draw ethanol. It will produce something that has 2 carbons, right? It must have 2 carbons. مش هنجيب كربون عندهم فاهم. Okay. And it will have the OH. It also have a double bond with oxygen. Okay, this is called carboxylic acid. It's another family of organic compounds. Okay, we will be discussing it in the next video. But this is called carboxylic. Okay, what else will be produced from this reaction?
Water.
Water. Why? Some oxygen, some hydrogen was kicked, and it will produce water. Okay, very good. However, this is not simple. We need some conditions to have this reaction going. So what are the conditions? We need heat. I'll tell you.
And catalysts.
Acidified potassium manganate. Okay. Ethanol can also be oxidized to ethanoic acid, an organic acid, okay, by powerful oxidizing agents such as acidified potassium manganate. During the reaction, the purple color of potassium manganate is removed as ethanol is oxidized to ethanoic acid, okay. Actually, this is not the correct equation. Let me 2H is atoms, not molecule, because the oxidizing agent is potassium manganate. So let me write it: ethanol plus potassium manganate, and with heat.
So we get the oxygen from the potassium manganate.
Oh, yes, this is what is the potassium manganate called? Oxidizing
Agent.
We need to close some tabs عشان iPad بطيء. Okay, this is oxidizing agent. What is an oxidizing agent? It gives oxygen. Okay, so the potassium manganate has a purple color. Color. And let me changes to colorless. Okay. Purple color changes to what? Colorless. Okay, mمكن. What is the purple? What's colorless? The colorless is what? Is the ethanoic acid. What is the color of water? Water is colorless. Okay, very good. Very good, Yaziko. Okay. Let's go further. So we said that the main the main alcohol out there is called what?
Ethanol.
Ethanol is the major alcohol used. It's used everywhere. So ethanol. So how do we manufacture ethanol?
By fermentation.
Wait. This ethanoic acid is called vinegar. Vinegar. This is the vinegar that you eat. Oh, يعني that you put on food. English. Speak in English. You have a speaking exam very soon. Yeah, English speaking exam. Speaking. So the last thing regarding alcohols. The last thing. So ethanol is the most major alcohol out there. So how do we make ethanol?
Fermentation from yeast.
How do we make ethanol? Good question. Tick 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 tick. So there are two main methods: fermentation.
And anaerobic.
That's in the fermentation. What's the other method?
Um,
We took it before in the alkenes. Alkenes.
hydration.
Hydration of alkenes. Hydration of alkenes. Hydration
Of alkenes.
or of ethene, because we're working with ethene. Ethanol. Ethene. Let me have it a clear E. Okay. So let's discuss the fermentation process. So what is fermentation? So basically,
Adding yeast to water.
sugar.
Water.
The yeast is called yeast is it's a fungi. It's a fungus that has some properties. It some sort of, if you add it on sugar without the presence of oxygen, it will produce ethanol. So yeast is a fungus. Add sugar solution to yeast, it will produce ethanol. Okay, so very importantly here is that no oxygen. There is no
Oxygen.
oxygen. Why? Because the chemical reaction happens in the absence of oxygen. If there is oxygen, it will form another thing. It will form probably ethanoic acid, not ethanol. So also temperature is very important. Temperature should be between 30 from 25
To 39.
to 35. Why? Because yeast basically malfunctions. Yeast will become denatured. The enzymes inside yeast will become denatured above 40 degrees. If temperature exceeds 40,
It will denate.
yeast will be ruined, or enzymes will be denatured. Okay, so let's type basically the equation. We have glucose, it will give me ethanol and carbon dioxide. Let's write a chemical equation: C6H12 alhamdulillah
Six.
O6. It's aqueous. Can you give me some tissues? It will give me a minute. This is glucose. Memorize this equation. Glucose, it will give me ethanol. What's the equation of ethanol? C2H5OH plus CO2. So let's balance this equation. It will give me two carbon dioxides, two ethanol molecules. So this is the balanced equation. 6 carbons. We have 6 carbons entering. We have here 4 carbon atoms, and we have here 2 carbon atoms. So it's balanced. Okay. An important thing: this is a slow process. Okay. It happens in batches. It happens in batches.
Okay.
What else? So what's a batch process? A batch process is one in which each batch goes through one stage of the production process before moving onto another stage. So in the production, it's not continuous. It's batches. When one batch finishes, the other batch comes in. Okay. When one batch finishes some certain thing in the production process, the other batch
Is added.
is
Is replaced.
is replaced by this batch, and this goes to the other phase. It's relatively slow, and also a very low percentage yield.
What does percentage yield mean?
The amount of useful outcome, the outcome that I want from the experiment, from the chemical equation, or chemical reaction.
So it will be much more expensive.
Not necessarily, but it has a low percentage yield. I'll explain percentage yield in other parts of the service, but not here. So it's about 15%.
Okay.
Okay. Also, we have ethanol, and it will be mixed in water. How do we separate ethanol from water? Ethanol is separated from water. How do we separate two miscible liquids from each other?
By heat?
No,
Hydra-
something called fractional
Fractional distillation.
distillation. Fractional
Distillation.
distillation. Fractional distillation. The iPad is very slow. Okay. So we finished the
Ethanol.
ethanol, the fermentation of ethanol. Key point here: yeast. It's a fungus. It's added to sugar solution. With no oxygen. Okay. Yeast, no oxygen for anaerobic respiration. Okay. This will produce ethanol. Temperature is between 25 to 35. If we increase the temperature, yeast will be ruined, or enzymes inside the yeast will be denatured. Okay, so basically we have glucose. It will give me ethanol and carbon dioxide. We also said this is a very slow process. It happens in batches. It's a batch process. It has a low percentage yield. So after the process is finished, ethanol is separated from water because the glucose was in water. So ethanol will be mixed with water.
Okay.
Okay. Ethanol is separated from water. How by fractional distillation. Fractional distillation. I'll stop the video now because the iPad is very slow. Let's compare fermentation to hydration. Fermentation
to hydration.
Hydration. Okay. So, what conditions do we need to make fermentation? Wait, what happened in fermentation? What happens?
We add
yeast
to sugar solution.
Plus sugar. No oxygen. Temperature 25
to 35.
to 35 degrees. Ethanol. Very simple. So what about hydration? What happens with the hydration? We got ethene plus steam. Give me ethanol, but it's a reversible reaction. Ethanol. So what conditions do we have? 300 degrees Celsius
and 6,000 kilopascals.
6,000 kilopascal. And what else? Phosphoric acid catalyst.
We produce ethanol.
To produce what? Ethanol. Okay. What happens? What else? The processing. We said that the fermentation is
manufactured in batches.
Batches. Okay, let me. Batches. And the hydration is a continuous process.
Yes.
Doesn't have batches. Okay, sustainability. What's more sustainable?
Fermentation.
This is sustainable, sir?
Yes.
Sustainable.
Because glucose is renewable.
As sugar or glucose is renewable. However, this is not sustainable as
it has a finite source.
Ethene is finite. Okay, purification. We have the ethanol.
By fractional distillation.
Ethanol is mixed with water. So it requires fractional distillation. Here, no purification is required. No purification is required. Percentage yield.
About 15%.
15%, and here it's 96%. It's very high. So each one of them has its pros and cons.
Yeah.
Okay, so let's say pros, cons, fermentation, and hydration. So it's low energy, doesn't need a lot of energy. It's very simple. It's a very simple reaction. Uses very easy material, readily available materials. Okay, cons, it's very slow.
Not a continuous process.
It's batch process, not a continuous process. So the hydration, the pros, it's very high percentage yield. It's fast, high percentage yield. However, high energy consumption.
Requires
It requires 300 degrees Celsius and 6,000 kilopascals. Requires ethene, which is not sustainable. So it requires ethene that is finite.
Mhm.
Requires finite. Okay, we finished alcohols. Thank you very much, Zico.